let's have few examples. First of all, we will have sketch the function and find its Fourier series. The function is fx is x square, x lies between minus pi to pi. So let me sketch the function first of all. So when x is minus pi, f of x is pi square. This is pi square, pi square. When x is 0, it is 0. When x is pi, it is pi square. So this is the graph is a parabola. Since the graph is symmetrical about y-axis, if you are folding this side along y-axis, so this part matches over it. Exactly. So this is an even function. It is symmetrical about y-axis. Since it is an even function, we have Fourier cosine series. Fourier cosine series, which is a naught plus sigma n equal to 1 to infinity a n cos nx. This is the series we were finding for even function, where a naught is equal to 1 over pi 0 to pi f of x dx. This is a naught we are going to find. 1 over pi as it is 0 to pi. Now 0 to pi function. Since the function is continuous, so 0 to pi it is x square. So let me write x square dx. 1 over pi as it is, let me integrate x cube by 3 and this is 0 to pi. 1 over 3 pi there and pi cube minus 0. So 1 pi goes, so the answer will be pi square by 3. This is a naught. Pi square by 3. an will be 2 by pi 0 to pi. f of x cos nx dx. Now 0 to pi f of x is pi square. 2 by pi as it is, 0 to pi it is x square cos nx dx. Now we have to integrate x square and cos nx. Since x square is polynomial, that is taken to be the first function. Let me have the tabular integration. Tabular integration cos nx. The derivative of the left hand side, 2x, the integral of the right hand side, sin nx. The derivative, the integral, 1 over n square cos nx. The derivative, the integral, 1 over n cube sin nx. And when the derivative is 0, you have to stop. So attach like this. Put a plus sign, a minus, a plus. Now the limits are 0 to pi. And if I am going to take this sin nx, so I know that sin n pi equal to 0 for all n belonging to integer. Sin n pi is 0. If you are putting x is equal to pi, sin n pi is 0. If x is equal to 0, sin 0 is 0. So that part vanish. Similarly, if I am coming here, this sin n pi and sin 0, they are 0. So from tabular integration, two terms, they are gone. We are left with an. an is 2 by pi, this 2 by pi as it is. So this is remaining. Minus minus plus. Let me have 2 over n square x cos nx. The limits are 0 to pi. this minus and this minus multiplied, 2x and 1 over n square, this is multiplied. So the limits are on x. Let me have 4 over n square pi outside. Limits are on x. Let me have the upper limit pi. Pi cos n pi minus the lower limit, x is 0. It is going to be 0. This pi goes and we are left with 4 over n square minus 1 raised to the power n. Let me explain that. Cos n pi. Cos n pi is equal to, when n is 1, it is cos pi, which is minus 1. When n is 2, cos 2 pi is plus 1. When n is 3, cos 3 pi is minus 1. When n is 4, it is 1. So and so forth. So cos n pi is written minus 1 raised to the power n, where n is 1, 2, 3, 4, 5. So this is. Let me calculate A1, A2, A3, A4. Since I have the general formula for an, 4 over n square minus 1 raised to the power n, let me have A1. A1 is 4 over 1 square minus 1. A2, 4 over 2 square minus 1 square. A3, 4 over 3 square minus 1. A4, 4 over 4 square minus 1 raised to the power 4, and so forth. So Fourier cosine series consists of two constants a0 and an. We have calculated a0 by square by 3 and an is this. We have a1, a2, a3, the required Fourier series. The Fourier series is therefore f of x is a0. A0 is pi square by 3 plus. Let me have sigma notation. A1 cos x. A1 is my 4 over 1 square. So this is 4 over 1 square cos x. A2, 4 over 2 square cos 2x. A3, 4 over 3 square cos 3x, and so forth. Look at that. Minus 1 raised to the power 3 is minus 1, so minus 4 over 3 square. So this is the required Fourier series for a function which is even function. Let us have another example. If I am going to take this and this is minus 1, 1, this is minus pi to pi, and f of x plus 2 pi is f of x. I have given the sketch. From the sketch, determine whether the function is even, odd, or neither even nor odd, and find the corresponding Fourier series. Since the graph is symmetrical about origin, since the function is symmetrical about origin, it is an odd function. It is an odd function. Odd function, we have Fourier sine series of the form, let me write, f of x is sigma n equal to 1 to infinity bn sine nx. For odd function, we have to calculate only one coefficient, which is bn. Bn will be 2 by pi 0 to pi. F of x sine nx dx. So we have to calculate only one coefficient when the function is odd. Formula is like this by using the properties. 2 by pi, 0 to pi. Now 0 to pi, look at the graph. 0 to pi, the function is 1. So you are not looking at this. Okay, what is minus pi to pi? What is minus pi to 0? No. Since the formula is going to be designed like this, so you have to look 2 by pi as it is, 0 to pi. 0 to pi, your function is 1. Let me write 1 here. And sine nx. And nx dx. Let me integrate now. Integral of sine is minus 1 over n cos nx. The limits are 0 to pi. So it becomes minus 2 over n pi outside. Let me have limit on x. Upper limit cos n pi. Lower limit cos 0. Upper limit pi, x is replaced by pi, cos n pi, and the lower limit x is replaced by 0, cos 0. So it becomes minus 2 over n pi outside, cos n pi again, minus 1 raised to the power n, and cos 0 is 1. Whenever you are having cos n pi, you have to put minus 1 raised to the power n. So Bn will be, let me adjust this minus, I am multiplying this with minus. So this is 2 over n pi outside, 1 minus 1 raised to the power n. So this is the general formula, right, for the coefficient Bn when the function is an odd function. This. So if you look carefully, you will see this bracket will be 0 when n is even. Even when n is 2, so minus 1 raised to the power 2 is plus 1. That cancelled with 1. When n is 4, when n is 6, it means once you are going to have n2, 4, 6, 8, that vanish. So do not calculate B2. So you are calculating B1, B3, B5 and odd numbers. B1. N is 1 everywhere. Minus 1 raised to the power 1 is minus 1, minus and minus. This plus. So 2 to the 4 by pi. B3, 4 by 3 pi. B5, 4 by 5 pi. And so on and so forth. Similarly, B7, so it will be minus and minus. Plus 2 to the 4 by 7 pi, so on. So the Fourier series then takes the form f of x is. So this is the series we have taken in the beginning. B1 sine x plus B2 sine 2x plus B3 sine 3x, because sigma means you are taking the summation. So I am going to write B1 sine x. B1 is my 4 over pi. Let me write 4 over pi sine x. Then B2 is 0. When n is even, it is 0. B2 I am not writing, I am writing B3. And B3 is 4 by 3 pi. 4 over 3 pi sine 3x. B5, 4 over 5 pi sine 5x, and so on and so forth. So this is the required Fourier series for a function which is odd function. For odd function, you have to calculate one coefficient, which is Bn. For even function, you have to calculate two coefficients, which is A0 and An. According to the formula, we have this. Let me have another example. When the function is neither even nor odd, let me write down the sketch, which is this and minus by this. This is by this one. So I have given the graph this time. Sometime give the function and you have to sketch and see whether even or neither even nor odd. According to that, you have to find Fourier series. Now this function, which is minus pi to pi, So I am writing one thing, 2 pi is equal to f of x. So that this is a periodic function. It means the next half it is going to be 0, and then this is going to be like this. And then similarly like, so this periodic function, it moves backward and forward. Now look at the function, it is neither even nor odd. If you are folding this along y-axis, this part is there, but there is no part over which it matches. Similarly, it is not symmetrical about origin. If it is there must be part coupled here. So, since fx is neither even nor odd, for neither even nor odd, we have to calculate all the coefficients. We have to calculate a naught, a n, and b n, all the coefficient. And the Fourier series will be a naught plus sigma n equal to 1 to infinity a n cos nx plus b n sin nx. This is the required Fourier series for a function which is neither even nor odd. So all the coefficient you have to calculate. Now let me discuss one thing. A naught is 1 over 2 pi minus pi to pi fx dx. This was the formula we have written originally when we were calculating the Fourier coefficient. A naught is this formula. Since the function is neither even nor odd, you have to write down this as it is. If you are written this as it is, let me look at the graph now. Since this is definite integral minus pi to pi, a definite integral, so looking at the graph minus pi to 0, you can split the limit according to the graph. So you can split minus pi to 0 plus 0 to pi. You can make as many partitions as you wish, but here in the graph minus pi to 0, the function is 0. Look at that. The function is 0. And 0 to pi, the function is 1 dx. Bracket is closed. A naught. A naught will be 1 over 2 pi. So I am integrating this, which is x, and the limits are 0 to pi. So it is half 1 by 2 pi, and it is pi. Pi goes, so half is the answer. Now an will be 1 over pi minus pi to pi, f of x cos nx dx. The same formula. You do not change 2 by pi 0 to pi. Those formulae for even and odd function. Since it is neither even nor odd, so you have to have the same formula. Again 1 over pi as it is. Now minus pi to pi, look at the graph. Look at the graph, so minus pi to 0 plus 0 to pi. Minus pi to 0, the value of the function is 0, which is 0 there. And 0 to pi, it is 1. Cos nx dx in bracket close. So 1 over pi as it is, I am integrating this because this is 0. So this is 1 over n sin nx. The limits are 0 to pi. So 1 over n pi, this is sin n pi minus sin 0. Upper lower limit. X is replaced by pi and x is replaced by 0. Sin n pi vanish and sin 0 is 0. So it is going to be 0. So an is 0. Because sin n pi, where n is 1, 2, 3, 4, 5. If it is an integer, it vanish and 0. So let us calculate bn now. Bn will be 1 over pi minus pi to pi f of x sin nx dx. Again, the limits are split up. Minus pi to 0 and 0 to pi. Minus pi to 0, the value of the function is 0. 0 to pi, it is 1. Sine nx dx in bracket. So let me integrate now. This is 0. Integral of sine x minus 1 over n cos nx, the limits are 0 to pi. This become minus 1 over n pi outside, upper lower limit on x. So this is cos n pi minus cos 0. So it is going to be minus 1 over n pi there. Whenever cos n pi, write down minus 1 raised to the power n and cos 0 is 1. Since minus is outside, that you are going to multiply with it. So it becomes 1 minus minus 1 raised to the power n. And again the same thing, it is going to be 0 when n is even. N is even. So you are calculating, this is Bn we are finding. Bn we are finding. So for even it is 0, let me have B1, let me have B3, let me have B5. B1, 2 by pi. This is 2 by 3 pi. This is 2 by 5 pi and so forth. When n is odd, the negative power of a odd number makes it odd, which is multiplied with it 1 plus 1, 2. So 2 by pi, 2 by 3 pi. So the Fourier series is f of x is a naught. A naught is half plus a's are 0. A's are 0. We're not writing anything. B1 sine x. B1 is 2 by pi. 2 by pi sine x. B2 is 0. B3 is 2 by 3 pi sine 3x. B4 is 0. B5 is 2 by 5 pi sine 5x and so forth. So this is the Fourier series for a function which is neither even nor odd. Find the Fourier series for the following. Number 1. This is minus pi and this is pi. Number 2. Minus pi. Minus pi. So 3 questions are given, you have sketches are given this time, and you have to find Fourier series for this. And what do I suggest is, for this, since the function is an even, if you are folding along y-axis, this part matches over it. So this is an even function, but you have to find the equation of a line. So this point is pi 0 and this point is 0 pi. So 2 point slope formula. If you are finding 2 point slope formula, you have to find this function, and then you have, this is fx which you are finding, and then find the Fourier series. Similarly, this point is pi and this pi and y-axis, this is pi given. So this function is neither even nor odd, you have seen. But find the equation of a line by 2 point slope formula, origin 0, 0 and pi, pi. So this is f of x is x, naturally speaking. F of x is x. When x is 0, it is 0. When x is pi, it is pi. This function, look at the third function, which is odd. Because in the graph you have seen it is symmetrical about origin. So you have to find equation of this line This line is required. Again the same thing. This is 0 pi, this is pi 0. 2 points, no formula. Find the equation. Since it is an odd function, find Fourier sine series. You have to calculate only one coefficient. Here you have to calculate two coefficients, but here all. But you have to find equation of a line by 2 points, no formula.